Hi guys, we are going to look at this O-level topic, mechanics, and precisely uniformly accelerated motion. So it's going to be very brief, and I am just going to give you what you need. So not into the details. All right, to begin with, there are some appellations in as much as we begin to talk about the laws or Newton's law of uniformly accelerated motion. Some of these appellations include, we have U. U stands for initial velocity, initial speed or initial velocity. We have V, which stands for the final speed or the final velocity. We have T, the time taken. We have S, which is the distance traveled. We have A, which is the acceleration. And finally, in some cases, we have G, which is acceleration due to gravity. For the moment, these are the appellations that we are going to be using as we are going to be talking about the Newton's law of uniformly accelerated motion. Now, I am going to be talking about the three laws. I said we are going to see these major appellations, and Newton postulated three equations that can be used to solve any question so long as the motion is uniformly accelerated in a straight line. So equations of uniformly accelerated motion. The three equations include V equal to U plus AT. Equation 1. Remember, V means final velocity or final speed, U stands for the initial, A stands for the acceleration, and T stands for the time taken. This is equation 1. Equation 2. S equal to UT plus half AT squared. Equation 2. S, the distance traveled, U, initial speed or initial velocity, T, the time taken, A, acceleration, and T stands for the time taken again. And finally, V squared is equal to U squared plus 2AS. Equation 3. So, hi guys, these are the three equations of uniformly accelerated motion. And in order to succeed with these three equations, I'll just give you some 3 tips that you just need to know before we move ahead to solve 1 or 2 questions that I will have to practically show you how these equations are being used. Now, the first thing I want you to know is that at times they are going to tell you that a body or a car or a vehicle or a whatever started from rest. Now you need to know that when an object is at rest, the velocity or the speed is 0. So if something starts from rest, it means that the initial velocity is 0. So if a body start moving from the resting position, it means that the initial velocity was 0 meters per second. Now all the same, when a body moves, consider a body that is moving upward. If a body is moving upward, it means that it is using acceleration due to gravity. So the acceleration becomes g, which is numerically equal to 10 meters per second squared. All right. So if a body is moving vertically downward or vertically upward, then at maximum height h max, or in the context s max, then at this height the final velocity is equal to 0. So if a body is moving upward, when it gets to the maximum height, it has to stop before it starts moving downward. So at that stage, the final velocity is equal to 0. And the third one is that if a body is moving, maybe it starts moving, it was initially moving at the velocity of maybe 20 meters per second and finally comes to rest. So if a body comes to rest, it means if a body stops after moving, then the final velocity is 0. It was moving at a certain u initial velocity and it ends up standing, meaning that the final velocity is 0. Now, mindful of the fact that when doing with vertical motion under gravity, the acceleration becomes acceleration due to gravity, which is numerically equal to 10 meters per second squared. So if a body is moving vertically, the first equation of motion becomes v equal to u plus gt. This is equation 1 under gravity. The second equation now becomes, instead of s, we are going to use the height, since it is motion, vertical motion under gravity. So we now have h equal to ut plus half gt squared, equation 2. And finally equation 3 now becomes v squared equal to u squared plus 2gs. So this is equation 3. And finally, this is all you need to know as far as the equations of uniformly accelerated motion is concerned. And this motion must be motion in a straight line. In case a car is taking a corner, or in case the car is portraying a circular motion or a simple harmonic motion, then you watch out. Maybe with time you're going to get more maybe another explanation for such. For the moment, we are simply talking about uniformly accelerated motion in a straight line. All right, that said, we are going to take 1 or 2 examples and we solve them for your better understanding. Okay, we'll take this question. We'll take this question. A car is moving with a velocity of 15 meters per second. Given that it accelerates uniformly at 2 meters per second squared to reach a velocity of 20 meters per second, find A, the time taken, B, the distance traveled. D'accord. This is the normal type of question that you're mostly going to be having, especially at the GC ordinary level. So let's get started. Remember, we are going to be using these same equations of motion in order to solve correctly the question. All right, we can get started. A car is moving with a velocity of 15 meters per second squared. This car is initially moving with 15 meters per second squared. So this one, 15 meters per second squared, is the initial velocity u. 15 meters per second. Sorry, 15 meters per second, initial velocity. Now, given that it accelerates uniformly at 2 meters per second squared, it accelerates uniformly, acceleration 2 meters per second squared, to reach a velocity of 20 meters per second. To reach a velocity, final velocity v of 20 meters per second. All right, now what do we want? A, they say find the time taken, t, and B, find the distance traveled, s. From the equations of motion, t can be gotten clearly from equation 1. And as a reminder, equation 1, v is equal to u plus at. This is equation 1, Newton's law of motion. Sorry, equations of uniformly accelerated motion. The laws of motion, Newton's laws of motion, are different from this. We have law 1, law 2, and law 3. They are different from this. These are equations of uniformly accelerated motion. Now from here, v is equal to u plus at. What do you need? T. So it is a call for you to make t subject of the formula. How do I do this? The first thing is to send u to the left hand side of the equation, and I divide by t. Finally, what do I get? V minus u is equal to a t, and I divide both sides by a. Finally, t is equal to v minus u over a. This is the formula you're now going to use. So now this formula is derived from equation 1, just by making t the subject of the formula. And now it can easily be solved. T is equal to v 20 minus u 15 over a 2, which is equal to 5 over 2.5 seconds. That is A. And B, what do we need? The distance traveled, S, from equation number 3. Equation 3 says S is equal to ut plus half at squared. And that is S we are looking for. S is equal to ut, u being 15 meters per second and t being 5 over 2 plus half a t squared. The t is 2 squared. This is what they call substitution, and you continue your solution. Now 15 times 5 is 75 over 2. Sorry, 75 on 2, and 2 squared, 4 times 2, 8, and half of 8 is 4. Now you use your knowledge of fractions to solve this equation by using the LCM. This is going to be equal to 83 over 2, which is the same as 41 and a half. And your answer, we are talking about distance here, so your answer is going to be in meters, because meters is the SI unit for distances. So here ends our solution. If you don't mind, we are going to look at a second example, and that's where we are going to end. Let's look at this question. A car moving at a velocity of 50 meters per second decelerates at 10 meters per second squared to 20 meters per second. Calculate the distance traveled. So let's get started with that question. A car moving at a velocity of 50 meters per second. This means that this car is initially moving at this velocity of 50 meters per second, and this car decelerates. Take note, this vehicle decelerates, and deceleration is equal to negative acceleration. It means acceleration is equal to negative 10 meters per second squared, because this is acceleration in the negative direction. And the car decelerates to a velocity of 20 meters per second. Now calculate the distance traveled. Calculate the distance traveled. To get started with this question, we are going to begin by looking. You cannot find the distance if you don't know the time. From here, you get back to the equations of uniformly accelerated motion that we enlisted in this video, and you see where we can go by finding time first. From the equation V is equal to U plus 80. This is equation 1. And from here, it can be clearly seen, like we already did this. It can be clearly seen that T, the time taken, is equal to V minus U over A. Hence, the time taken is 20 minus 50 over negative 10, which is equal to neg 30 on neg 10. Mathematics students, this is equal to 3 seconds. Now you can take the time 3 seconds and you substitute in the equation S equal to UT plus half AT squared, and your answer for the distance is going to come out. S you substitute is equal to UT 50 times 3 plus half A negative 10 AT squared. Now 50 times 3 is 150 plus 90 plus negative 90 on 2 half. So it's the same as 150 minus 45, which is equal to 105 meters. So that's fine. Alternatively, there's another method 2. We can still use equation 3, the third equation of uniformly accelerated motion. This equation is v squared equal to u squared plus 2as. Here we must not use the time. You can use this directly without looking for the time. So you can just use this information in this equation to solve for the distance. How do you do this? You make s subject of the formula, and you're going to have s is equal to v squared minus u squared all over 2a, which is 20 squared minus 50 squared, all this over 2 times negative 10. When you operate this out, you're going to have 20 squared is 400 and 50 squared is 2500, something like that. All right, so you're going to have 400 minus, you have negative 2100 over negative 20. Now the negatives will have to cancel out, and you are going to be left with 2100 divided by 20. You're going to be left with 105 meters. All right, if you want to notice, you can notice that you have the same answer with the one above. So either method, whether you choose to go by finding first of all the time, or you go straight with this formula, you're going to have the same answer. All right, so with this explanation, you're able to right now you're able to solve any question in this section of mechanics. You're able to solve any question in as much as the equations of uniformly accelerated motion are concerned. And it's a very fertile area, especially at the GC ordinary level. It was a nice time. Have a nice time. Have a blessed day.